We've discovered the power rule. We derived the power rule. Now we're going to use the power rule. So let's get started. We have f of x equals 3x squared plus x. Our rule, x to the n, the derivative of x to the n is nx to the n minus 1. So f prime of x, bring down the 2 from x squared, is 3 times 2x to the 1 plus the derivative of just x, we bring down the 1, and then it's x to the 0. Okay, now that 3 in front, like a limit, we have that limit property where we can bring the constant out of the limit. We can do the same thing here with the derivative. If we're multiplying by a constant, we don't really need to think about that when we're taking the derivative. We just leave it alone. Okay, so that 3, yes, it's going to stay in front of this term, but we don't need to derive 3, okay? So this will become 3 times 2, 6x. We don't need to put the 1 there. And again, we don't need to put x to the 0. We can just put 1. So f prime of x equals 6x plus 1. G prime of x. Well, here we have 9 times the square root of x. The square root of x doesn't look like a power, but is it a power? Some of you at home are thinking, yes, it certainly is. And some of you are thinking, oh my gosh, I forgot that it is. Or is it? So remember that the square root is the same as x to the 1/2 power, okay? So g prime of x is going to be, remember, leave the 9 alone, multiply by the power 1/2 times x to 1/2 minus 1 is negative 1/2. And we can rewrite this. We can rewrite this as g prime of x equals 9 over 2 root x. To x to the negative 1/2 is 1 over root x. H of x, what is going on here? There's no way this could be the power rule. We have 11x to the 7th plus 3x to the 5/2 minus x all over 2x. How could this be the power rule? We have something divided by something else. That shouldn't work. Now, I want you to think how this is the power rule while I start writing. So if we're dividing by something that we can divide each and every term by, in this example, 2x, we can divide each of one of these by 2x, then we still can use the power rule. So 11 over 2, x to the 7th divided by x is x to the 6th, plus 3 over 2, x to the 5/2 minus x to the 1st is 3/2, minus x over x is, well, that'll be minus 1/2. Okay, h prime then is 6 times 11/2. Well, let's write that separately. 11/2 times 6x to the 5th plus 3 over 2 times 3/2 x to the 1/2. The derivative of 1/2, remember this is x to the 0. So this just goes away. The derivative of a constant is just 0. And I guess I'll write over here, 6 times 11/2. The 2's will cancel. We'll have 33 x to the 5th plus 9/4 x to the 1/2. Okay, and that was h. Here we have something nasty. We have p of t is equal to pi over t to the 4th. What do? We have 2 variables. Do we have 2 variables? Well, not really. Pi is not a variable. Not really. No, we don't. Pi is a number. Pi is 3.14. I know it looks like a variable because it's not a single number like 9, but it is just a number. So we can rewrite this as pi t to the minus 4. And then we can take the derivative, p prime of t. Pi we leave alone. We bring down the minus 4, so minus 4 times pi t. And is this going to be t to the minus 3 or to the minus 5? Remember, negative 4 minus 1. We keep the same rule, will be t to the negative 5th. Okay, we could rewrite this negative 4 pi over t to the fifth, if we wanted. And then finally, I have something kind of gross here. And I want to show you new notation. So before we were just saying h of x and then h prime of x, or p of t and p prime of t. Now we're writing d dx. d dx like this, or d dt, is like a command. It's telling us take the derivative. So this is telling us to take the derivative of y. And when we do this, we could write this as y prime, or we could write the derivative as dy dx. This is another way to write the derivative. So I'm going to write y prime there. So we remember that that's exactly the same thing. Okay, and now power rule. 23 x to the e, we can still do this. 23 times e, e is just a number, x to the e minus 1 minus x to the negative 100. Negative 100 comes down, it'd be plus 100, x to the negative 101. Okay, so there were a few problems practicing with power rule, and we saw a couple confusing things, but we found that we always just use the same rule. We don't need to change anything. If we get x into the proper form where it's to an exponent, we always bring that exponent down and then subtract one from it. I'll see you in the next video. Keep studying.